Hi everyone, welcome to our webinar today. We're going to wait a few minutes just to make sure we get as many participants as possible, and then we'll make a start. So we'll probably leave it 1 or 2 minutes to let everyone join. So to see the numbers going up there. But yeah, we're looking forward to helping everyone with a bit more education about the bus and coach fire protection side, covering R107 and the SPC R183.
Yep, so we've got 18 participants. I know we've got lots of participants from, again, all over the world, so thank you very much for tuning in and coming and having a look at what we do, what's bus fire protection, what do Reacton offer for protecting customers and end users against fire. Some of the technologies we're going to be covering today, look at also covering to different areas that we do. We'll be looking at some of the new innovation as well we've got for fire protection. So we'll give it another couple of minutes. Hopefully everyone can hear us. If you can't hear us, just drop us a chat, and we'll do the best we can if we have any technical issues.
If with Emma who's logged in, are you able to just give us a confirmation on the sound? Just make sure we're all good.
Yeah, she says it's fine. Sounds a lot better. We'll kick off here in a couple of minutes.
What we're trying to do is make sure we have plenty of time at the end to go through any questions you may have, and we'll do our best to get through as many as we can for you guys. I'm going to make a start in a minute.
Right, okay, we make a start. I'm sure there'll be some people joining us in another couple of minutes.
Yes.
Right, so welcome guys to the Reacton Bus and Coach webinar. We're going to be looking at both, I'm Ed Barnes, I'm I'm the Chief Technical Officer at Reacton Fire Suppression.
And I'm Ed Shivers, I'm the Global Product and Certification Director. I've been here for quite a while now, and looking forward to sharing a lot of knowledge that we've gained over the years through our hard testing.
Okay, so we're going to kick off now. Hopefully you guys can see the screen. Okay,
great. Okay, so today the webinar is going to be on our bus and coach systems, and we want to really give everyone a nice overview of what's involved with the systems, and really there's the couple of standards that are out there at the moment that people need to have a bit more of an understanding on, and the products that Reacton can offer to help mitigate these fire issues. So, as we want to start off with, what is automatic bus and coach fire suppression? So when we talk about automatic suppression, we're talking about either it's going to suppress, which is controlling the fire, or extinguish a fire event, which is obviously putting out the fire completely. And then when we talk about the automatic side, you have a detection system which is linked to a cylinder or a container, a vessel to deliver the extinguishing agent, but it is completely autonomous. Doesn't need any human intervention for this to happen. So we're not relying on anyone to spot the fire or know the telltale signs of a fire for this to take effect. And when we talk about automatic fire suppression systems in this arena, they are normally in the total flood or local application method, and more than likely they are pre-engineered fashion, which means that everything has been tested and you have a set of limitations, and as long as you keep within those parameters, you have a system that is designed and tested to work. And what we have here is a system which has agents which have been specifically chosen for its application. So with bus and coaches, we know that there's a Class B risk there. There are some Class A's and everything like that. And the mediums that we use are already tested to tackle these fires.
Yeah, and I think that's an important point, that a lot of there has been attempts to re-engineer different types of chemicals that are used in vehicle fire suppression, but such as aerosols and different types, other different types of gas-based systems. But we choose the most, we choose the most established and tested chemicals for the systems that we sell that protect buses. And I think that's an important point. The technology that we keep developing is to make better use of those extinguishing agents, whether it is dry chemical or wet chemical. And
this slide, we'll go through just really quickly what a typical automatic suppression system looks like. Really, they are made up of some key components. And the first one, the main one really, is the extinguishing agent storage system. This is the pressure vessel. So they come in all different sizes, but what we have here is basically a vessel which holds an extinguishing medium, which is designed for the application, and it can be stored pressure. It can be not under pressure and has a nitrogen source to drive it. Then we have the detection system in the bus and coach application, and specifically vehicle. The linear sort of detection tube, electrical detection methods are the preferred choice because of the way that they can easily be routed. An engine bay is very congested, and spot detectors and those sort of applications aren't really perfect for that environment. Then we have a distribution network, which is another word for your pipe and your discharge hoses that lead from the cylinder to your nozzle. You have an actuation system, which really controls the actuation of the fire suppression system. And in the Reacton product, we have our patented CTX valve, which has it's a very simple method of actuating, but there's a lot of design and hard work that's gone into making this valve. But the principle is very simple, where it's a pressure loss system, and its natural state is for it to activate when there's a pressure loss in the system. So it's ultra reliable.
Yeah, and it's a single moving part. That's been the design philosophy for Reacton's products, not only in the bus industry, but also in the heavy equipment sector for plant and machinery. Is a lot of systems on the market need a number of components to work in a set order. And if one of those components fails to work, the entire actuation of the system, or the point at which the system delivers and activates, fails to work. So the Reacton system works with the principle of one single moving part.
And most importantly, like I had said, there's no power required for the system to operate, which is one of the very unique things about the Reacton system, and gives it that ultra reliability. And then on that previous slide, we had some bits about the ancillary functions and equipment. These are such as your manual actuator, your engine shutdowns, and battery isolation, these sort of devices. That's what they've covered. So moving on to this slide, we're talking about why these bus and coaches need an automatic vehicle fire suppression. And really, it's very easy to start worrying about protecting the vehicle and everything, but the buses and coaches they're transporting the most valuable cargo you can have, which is humans. This is something that we all, the reason why we get out of bed in the morning to do what we do is to protect life and critical assets. Here we've got, with the bus and coaches, they have a really demanding life. You know, they are worked very hard, and they do have long service intervals, which increases the wear on some of the components, which can then in turn, you know, lead to failure. And with any sort of engine in a vehicle, you have high temperatures, but it's much more focused in buses and coaches, because there's a lot of environmental and stringent noise and emission controls that have come out, where the engines have to work much more efficiently, but the temperatures in there have been increased significantly. And you know, there is a very quick trend to the environmental sort of controls and the way that the energy and the heat in the engines have increased. So it's a perfect environment for a fire to start. And the last point we've got on here, which is very important, and it will be shown in one of the videos we'll be showing in a minute. The engines are typically located at the back, and the operator, you know, doesn't really have any line of sight to see that. So by the time they realise that there's a fire scenario, it is usually too late.
So yeah, we've got a couple of videos now, so we're conscious to make sure the videos play as they should. We may skip between the videos, that's on purpose, as we show you different camera angles of the fire. But this is a typical, this is one example of how quickly bus fires can develop and how unaware the operators are that a fire has been established. The first notification this particular driver gets of fire is actually from other road users. So that gives you an idea as to how unaware the driver is that there is a fire coming from the rear of the vehicle, as Ed just said. So we've muted the sound, there is sound to this, and you'll be able to pick this up when you get a copy of the presentation. So I'm just going to, we've got a driver here that pulls the bus over to warn them that there's actually a fire going on. This is actually how the passengers start evacuating from the bus. The driver is completely unaware that there is a fire on the vehicle until that vehicle pulls over in front of the vehicle to stop it. So this is onboard footage, and this gives you an idea of how quickly fires develop. And this kind of fire scenario you see is typical where fluid, combustible fluid, has come into into contact with hot surfaces on the engine. So this fire develops very rapidly. That's not necessarily the same for all fires. Some fires can take a while to establish, but in this case, from the exterior camera, you'll see in a minute how quickly the fire develops. And often the other limiting factor on buses, and one of the reasons that it's critical to fit a detection and an automatic fire system, is the fact that when the vehicle is driving forward, the smoke and the smell of fire is obviously being forced backwards due to the airflow over the vehicle. So you can see when the bus has stopped, and this is when the car pulls in front of it, you can quickly see the cabin and outside, particularly outside of the vehicle, it developed very quickly into quite a scary environment for the passengers. So this, I'm going to skip through this, and what you see is the driver realising when the vehicle pulls him over, and then we're going to look at some exterior shots now of the vehicle, and we'll very quickly see how the fire develops when the flammable liquid comes into contact with a hot surface, such as a manifold or a turbocharger in the bus. So you can start to see the smoke, and this is typical of other videos that we'll be able to share with anyone who contacts us. You can see some very quick ignition now taking place from the rear of the vehicle, and again, that's typical from a combustible fluid coming into contact. And it's quite amazing actually how quickly these fires develop, because not only is the fire coming from potentially a burst hydraulic hose, or a burst fuel line, but obviously the fire also develops on the surfaces where the fluid is leaking onto, so on the road, on different areas, in the engine bay, often sprayed all over the engine bay. So that's a quick overview of one video, and you can see the fire very quickly develop out the back of the vehicle. So all's well at the moment with the passengers and the driver, and very, very quickly you'll see some sort of hose give way, and then you'll see immediate ignition, which you can see here. And obviously as the driver drives away, it's just adding oxygen to that fire, and obviously the effects of adding oxygen and more fuel to the fire lead to a bigger fire. So that's one particular video of an onboard bus fire. Now, what we haven't talked about is the human element. I know Ed touched on it a minute ago about that was a relatively calm evacuation from the bus. Now, this bus here is not powered by diesel. This is a gas-powered bus, and what you can see is the difference in how the fire behaves, but also because the fire is much more developed in a very short space of time, you can see the panic, the human element, and how it becomes a real danger that the safe evacuation of buses becomes very difficult. So you can see, if you can see my mouse, guys, you can see that there's a fire, a very light flame, and this is typical of a gas fire on the left-hand side here. So you can see everyone evacuating from the bus. There's even fire coming out where people are exiting the bus on the steps. But now you can see you've got a lot of people on a bus that now they're tripping up each other, falling out the bus. Yeah, and there's a number of people coming into contact with the flame that's actually coming out under the exit path. So, you know, it's not just the ability for us to save the asset or save the bus, but, you know, in this case, I would argue that it's not even safe to, it's always very difficult to safely evacuate the passengers on that bus. So, and you can see very quickly that the established fire, because there's no fire suppression system, is very difficult to fight, and it fully develops into a very uncontrolled fire. So I know a lot of people will say sometimes the questions we get asked is, you know, it's a small fire, people have plenty of time to get off. That's not the case with some types of fires, and especially those for wheelchair users or elderly users that have access requirements. It's not the case that they're able to easily exit the vehicle.
And it's, you know, like Ed said there, it's the egress time, and all it takes is for someone not able to leave the vehicle as quickly as other people, and they are in control of by that person. And it's not always the fire that's the issue. There's the smoke, and again, you're in a confined space, and due to all these emission controls and noise controls, there's lots of insulation that is used in the engine bay, which can obviously add a lot of smoke and, you know, a lot of damage to anyone who's on that vehicle. So there's a lot of factors there, but what we want to try and do is to make sure we deal with fires at the earliest stage. So on here we've got some pretty striking stats about the bus and coach fire data. We've got 63% of bus and coach fires start in the engine bay, and 19% was in vehicles being destroyed. And this is a huge number there. 2,130 bus fires attended each year by fire and rescue services, £2.7 billion paid out each year from insurers to commercial vehicles, and then 12 London bus fires every month. That is an incredible stat there. And then the last one, we've got 45% of road vehicle fires due to mechanical failure or malfunction. And what we're moving on to here on this slide, we've got quite a bit to get through, so we will push on. There are really, there's quite a few different mediums out there to protect bus and coaches, but really, as we mentioned at the start, we're focusing on the ones that are tried and tested, and they're proven, the ones that pass the test time after time. And this is the dry powder and the liquid-based ones. But first of all, we've got a dry powder system here shown on the an R107 6 kilo on a system that Reacton have done for a demonstration, which should play.
So what you can see is the dry chemical, unlike a liquid-based agent, is able to fill the engine compartment. And one of the things that you see inside buses, particularly smaller buses rather than actually the larger buses, the engine bays are very complex. And I'm just going to pause this video to talk through this. So you can see that there's a number of hidden trapped areas where, in that first video where you saw the flame take hold very quickly as fluid came into contact with the engine, that fluid can spray inside and around all of these components. Now, with a wet chemical-based system, what you find is that unless the fire is directly beneath the nozzle, you are going to have a situation where it cannot extinguish that fire. And in the testing that Ed will come on to later, that's described as a hidden fire. And it is, in essence, a hidden fire. It's a fire that's tucked away or beneath an object, or it's obstructed, of which wet chemical systems are unable to tackle. And we'd all agree from a suitable risk assessment that there are hidden fires located in all vehicles. So that's why, although we have access to dry chemical systems, wet chemical systems, and other extinguishing mediums, the primary agent we use is dry chemical, because, as you'll see at the later part of the slide, it performs better than any other agent as tested, which we'll run through as we get to the end. I'm just going to skip this slide. The persistent video, I'd like to play.
So yeah, really the key advantages of dry powder is the instant fire knockdown. And again, you'll see that through some of the testing videos we have. 5 times more effective than mortar by weight. Superior coverage, as you can just see from that video you just seen, how effective that it gets absolutely everywhere within that engine bay. It doesn't need direct sight of that fire for it to work. And again, it's the highest scoring extinguishing system in the SPCR approval range. Disadvantages, we know that it has minimum cooling properties, and it will require a clean down after discharge, but that is the same for all systems after a fire event anyway. And then we move quickly onto the liquid-based systems. You know, it has excellent cooling properties, which then helps for the reignition protection. We know this from experience as well, but there are quite a few disadvantages with just a purely liquid-based system. Requires significantly more nozzles, and we've got some facts and figures of how many more it does in regards to the R107 testing and the PMARC testing, which we can see has more agent typically, and not always suitable for electrical risk, which dry powder is, which protect the A, B, and C risks. And there's no 10 out of 10 or A+ rated system available on there.
And that means, and that means in real layman's terms that in a like-for-like comparison, if you complete a suitable risk assessment for a road vehicle such as a bus, we know that is there a chance that there are hidden fires. Now we know that in all risk assessment situations, in all bus engines, there are hidden fires. Now, the way that you could get around those with liquid-based systems is to fit nozzles in every single area where there are the likelihood of a hidden fire. But the majority, well, all of the installations that take place that are liquid-based don't do that. So the reason for it is you would require 30, 40 nozzles inside an engine bay and a significant amount of liquid to support those nozzles, and it quickly becomes very uncommercial for that type of system. So that's why the fire systems don't deal with all the liquid-based systems are not rated to A+, because they just simply cannot deal with certain types of risks. So what we're going to show you is a quick video of what we mean by hidden fires and the ability for liquid systems not to extinguish them. Now, this is a water mist system. Now, this is not on a bus, so I'm sure you guys have worked that out. This is actually on an industrial shredder. And what we've got is an engine, and hopefully you can see my mouse on the screen. The engine sits above this area. And what you're going to see is you're going to see a fire develop at the bottom of the engine. Now, you can see, hopefully you guys can see the fire that's developed here on this machine. Now, this particular fire isn't picked up very quickly by the fire suppression system's detection. And what we find is the fire is able to build in size and strength, and it's generating a lot of heat. Now, the other disadvantage of a liquid-based system is there are a lot of complex calculations which unfortunately don't get taken into account when specifying if there is enough droplet size to be able to extinguish a fire without evaporating. We all know water evaporates when you heat it. If it evaporates too quickly, it's not going to penetrate to the bottom of the fire. But in this case, we have another problem, which is where the system isn't certified to deal with hidden fires. So what we're going to find is that as the system discharges, so we'll let the video play now on this point, so you can see the flames coming from the top of the industrial bit of equipment. I'll just let this roll for another couple of seconds. So now what you can see is the fire system will activate, and you'll see all of the steam being generated, or the liquid being turned into steam, which you can now see. It's successfully suppressed the top part of the fire, but because it has poor penetration and because it's unable to deal with hidden fires, you can see that the fire is still ignited and still lit at the bottom of the machine. So while a lot of people talk about cooling properties of liquid-based systems, what they don't talk about is, can they extinguish the fire in the first place? And if the system can't extinguish the fire in the first place, then it's very irrelevant, the cooling properties, because you haven't extinguished the fire. And what we find is the system discharges for 40, 50 seconds, providing cooling, as you can see, but inevitably the cooling capacity runs out as the agent runs out, and the fire continues to burn and the machine burns to the ground. So suitable risk assessments are one thing, but fitting a system that is designed to deal with these types of fires is what we work with OEMs and our customers to specify, because the failure of this piece of fire suppression system is it was inadequate to deal with a large fire, but it was also inadequate to deal with a hidden fire risk that was presented in front of it. Okay, so we crack on to an overview.
Okay, so we've now gone through the extinguishing agents and the advantages and disadvantages of the different types that are out there. We know why these applications need fire suppression, and we know what automatic suppression is now. What we've got here is a nice overview of a typical Reacton system. And if we start at really at the front of the vehicle and work our way back, on here we've got our in-cab, and this is where the operator is able to see all the status of that system. And depending on the type of application, there may be smoke detectors that are linked to this, sounders, voice notifications, but it also gives a readout of engine temperatures and the overall status of that fire suppression system. And then if we work our way back, we have the next one here, which is the storage system. The Reacton system here shown is an R107 one. We've got an extremely compact system. We've managed to get R107 with a 4 kilo system here, and it packs an incredible punch for just its system size. Again, because of the dry powder superior fire knockdown abilities. Okay.
We won't cover that because I think that's immaterial. So
yeah.
I just want to make sure. So that's.
And really, the way that the system is detected is using the Reacton detection tube. Again, completely pneumatic, doesn't require any electricity. It's routed around where the risks are, and when this heats up from the radiant heat of fire, it will burst, and then it initiates the discharge sequence. And then the agent is delivered through the nozzles that are strategically placed as per your risk assessment to deliver the agent in the best manner.
Yeah, and the first point I just wanted to add, which is we talked about the importance of the driver being made aware of a fire taking place behind him, because as you saw in those previous videos, the seconds count when it comes to evacuating people from the bus. So not only do we provide a visual notification, but we actually provide a number of audio alerts. I'm going to try this, and hopefully this works and you guys can hear it. So, oh, clicked it twice. So, okay, I don't think you can hear that. I'm just getting some feedback. So basically that's just an audible alert that says, danger, the Reacton fire suppression system is activated. please evacuate the bus in a timely manner. So what we're doing is, and we also give different audio prompts to the driver of the vehicle, such as when they turn the ignition on the bus, they get a prompt that says, the Reacton fire suppression system is active with no reported faults. And if there is a fault with the system, they start the bus and it will say there's the Reacton fire suppression system is active but with system faults. So we're reporting to the driver, not only is the system okay, we're also talking about smoke detectors, as Ed talked about. In the case of electrical buses and hydrogen power buses, you've got gas detection sensors that we can integrate, so we can say that there's gas been detected. We can say we can fit a flame detector that says flame has been detected. So we've got a real nice customizable system that can be tailored to individual customers and also individual OEMs. So it's a really good customizable platform to operate from, and it really brings good alerting to the driver, which is really important to make sure that we get that life-critical asset off the bus, our people. So for us, the notification for the driver is the key part, along with the fire system. So let's see if we can get this moving on.
Yeah.
Oh.
Moving on to another sort of specification that Reacton have here, it's the TfL, the Transport for London spec system, where, again, what Ed mentioned about this, the in-cab system, which gives all the alerts and notifications, is configured in a set way as per the document that the TfL have launched, which means that we have to have certain notifications which are used at certain times. Every time the vehicle starts, we must have smoke detection on double-decker buses, we must have a beacon sounder, and also there must be engine, well, not so much engine shutdown, but it must stop certain fuel pumps and engine fans. So this caters for all of that. And we have the supporting documentation shown here, where we try to make it very easy for people to understand the system. We try to make the system as compact and as simple to install as possible, but we also have all the documents to make living with the system as easy as possible.
Yeah, and I think that's a key part with the system, which Ed will come on to, but the training and support of the systems from Reacton is obviously just as important as the system as itself. So we have world-class documentation that goes through the quick installation of the system, the wiring diagrams, and that's all wrapped up in what we would call an R107 product offering, which is specifically for London. So if any of you watching have a specific requirement, a different type of fuel, the system can be customized to suit whatever application we want to throw. Just quickly going to draw your attention to the screen that's up here. So you can see that we alert and flash red when we get smoke detection, and that could actually be in the toilet, or that could be on a double-decker bus up the top deck. We have an engine temperature monitoring loom, so we can monitor the engine bay temperature. So what we're trying to achieve there is a predictive system where if the engine is rising above a normal temperature range, that hopefully the driver can identify that and pull over and see if there's a mechanical fault before it develops into a fire. Because you know, for us, the mantra about fire suppression is it's always about fire prevention first, then fire suppression second. We've got alerts if we've got that, and you can see if there's a mechanical fault or the system gets a green tick if it's okay. So I think that covers the sort of general layout of the offering for the system. So it's just going to talk quickly about the certification.
Yeah, we need to rattle through this because I know that we want to make sure we've got time for questions. But this sort of stage of the webinar, just going to quickly talk about what the two sort of standards are really around sort of the bus and coach. And where we see this E5 logo here is the UNECE Regulation 107, and this is a set of legislative documents that give this framework for the coach operators and builders to make sure they have a system that is compliant. And part of that is the fire suppression system that is installed on vehicles. And this is mandatory for any of the contracting parties. I think it was around July 2018 it came into force, and then there's a set of series of dates that come in with the different stages of vehicles of when they become mandatory. And as you can see here, it's specifically aimed at engine compartments, single deck, double deck, rigid or articulated vehicles, category M2 or M3, specifically for vehicles having a capacity exceeding 22 passengers.
And this is described as the minimum. This is the minimum specification. And what you're going to see is the danger of, although it's the minimum specification, there are a number of fire suppression providers that offer R107 systems. But what a lot of people don't know about R107 systems is the only requirement to gain a certificate is simply to put out 5 fires. And actually, when we look at PMARC as another standard in a second, it takes 2, maybe 3 years to gain certification where the fire system needs to extinguish a minimum of 6, but up to 10 fires. And in our case, we outperform all of the global test or the competitors when it comes to the PMARC scoring system. But also the PMARC looks at a long durability, so it tests the system for vibration, corrosion. They come over here and they inspect the factories in which the components are made. They test our quality system. So an R107 system is a really cut down system, but the danger is that the system has never been tested for vibration. And we often find from looking at competitor systems, we find plastic bits inside cylinders that would never stand the time of vibration, but unfortunately the mandatory standard doesn't look at vibration. So yeah, based on 4 fires test outlined by SP method, and the SP method is what PMARC is based on. So we'll just quickly run through what PMARC is based on.
Yeah, and again, this is their quality labels where you see that, you know that the system has gone through a load of stringent tests that are internationally recognised, such as the type testing from the fires, but also the mechanical resistant tests, such as temperature cycling and vibration and corrosion, which I'll go into detail a little bit further on.
Yeah. So we'll just flick on to the next one.
Yeah, so here, we've got the 11 tests shown here. The 11th one is the reignition one, so we always talk about 10 tests. And what you can see here is the ones that you have to do and pass to be able to get an R107 system. But when it comes to PMARC, you can see that the Reacton system here has actually got 10 out of 10. Whereas, as Ed mentioned before, only 6 of those are mandatory to be able to get the certificate, which Reacton won't settle for that. We want to make sure that we have a system that can put out all fires.
So yeah, and that refers to when we were talking about the class of fire, we talked about hidden fires, and you can see that no R107 system is ever tested for hidden fires. And when we come on to, there's a comparison table, I think.
There was that comparison table, but here we really pick out what does that actually mean in the real life. So, okay, 4 tests versus 10, but what does that actually mean to you as a customer and a person installing these systems? So these sort of bring it home a little bit more. So with R107, there's no thorough component testing. So you're putting a system on there which has never been subject to any harsh operating conditions or vibration or anything like that, unless the manufacturer can provide that. But it's not mandatory for that system to have that. And this is where the SPC R183 does have that. There's no third-party review of your risk assessment, your installation documents. With PMARC, the SPC R183, these are gone through in extreme detail, and they have to be precise for us to be able to get that approval. And then we talk about an airflow. In the previous slide, you could see that there was 4 tests for the R107, and one of those goes up to 1.5 cubic meters a second. If we exceed that, which can be quite common in bus engines, we don't know if that system works. It doesn't have to pass that. Whereas in a PMARC 183 system, we could go up to 3 cubic meters on that. So really, you do need to make provisions to shut down the engine if you go above that from your risk assessment. No Class A risks are tested in R107. They are in the PMARC. And then we have the hidden fires. This means that when you're adding your system, you need to be careful that you get direct application from that agent coming out of that nozzle where it is needed. And this typically means you will need much more nozzles, and then that will in turn make you have a bigger system. So there's a lot of factors there that a lot of people don't realise, but when you pick a PMARC SPCR 183 system, you get all those parts covered.
Yep. So what we're going to see is we're going to see some videos now, and we're going to compare a R107 test to a PMARC test, and you can see the difference in. I'm just going to mute this. So we're going to turn the sound off. Otherwise, I'm sure some of you wearing earphones might have a headache afterwards. So the way the test procedures work, so this is a fire test for R107, is the counter, we light fires, and then basically at 1 minute 30, you close the door to the test enclosure. And this is to simulate a 4.5 cubic meter engine bay. So this is what both standards, PMARC and R107, are based on. And we don't activate the system automatically. We manually activate the system at 2 minutes, and that's part of all the tests. So that allows the fire to be established. So that's a relatively, well, it's the easiest test to pass on R107. It shows you the difference in the fact that it's a relatively small fire. There was a small diesel spray present in the back to simulate a ruptured hose, but it was a relatively easy fire to extinguish. And the testing for R107, is significantly easier, as we talked about in the previous slides, to PMARC. Now, if we fast forward to a PMARC 183 test, and this is the highest fire load, so this is the highest wind speed, the worst case scenario of fire. And again, at 2 minutes, we manually activate the system. And you can see there is an enormous difference with high wind speed and a larger fire. And you can see that the airflow is pushing oxygen in and the extinguishing agent out. So that's why between those two videos, you can see the difference between no airflow and the highest airflow. We're going to quickly march on because I'm conscious that we're going to march through the time. So this is some of the other testing that the systems go through with PMARC. So these are environmental tests, corrosion, salt corrosion tests, and mechanical vibration tests. The key thing with the Reacton system is even the R107 system, despite it not being a requirement to pass environmental salt and vibration, our R107 components are also PMARC tested. So a lot of fire suppression providers will offer you a cut down system with certain components, but most of the components that feature on our R107 system have also been through the PMARC approval. And that's part of our uniformity when it comes to components across the systems.
Yes, really, this is just a quick route of how you get the PMARC. There's a lot more that goes on, but really, the first stage is your type testing through the fire test, as you can see the report there. Then the next one, we've got the mechanical resistant tests, which mean that it goes on a vibration rig, and 96 hours of vibration, extremely hard conditions. Then you've got the corrosion tests, and all of that leads you to have a certificate at the end. And Reacton are really proud to be able to have an A+ rated system. And what we need to really bring home is that there's so much that goes into the PMARC behind the scenes to be able to achieve that certificate. And just to give you a peace of mind, just a little fact about the system, after it being on a vibration rig for 96 hours and then having 5,060 shot tests at 10 to 20 Gs, it then has to discharge. And we discharged all of the 9 kilo apart from 6 grams of powder. So it shows how effective the system is.
And that's kind of robust testing that Reacton does, not only for its bus systems, but also for its heavy equipment systems, its military applications, and anything that's going on road or is subjected to vibration and harsh conditions goes through a similar type of certification. So whenever you're asking someone where does their system sit from a performance rating, they'll be able to provide you a certificate, and the test scenario rating here will tell you what the performance of their system is. and then just make sure that the system size represents what's fitted.
And
so just blast.
Yeah. This slide here is really just to give you an overview of the testing that we've got. And I know throughout the webinar we've been sort of saying about the disadvantages of just settling for an R107 system. Reacton have 2 approvals, and the smallest system, one of the smallest systems on the market today, with our 4 kilo and 4 nozzles. So yeah, we've done a lot of testing there, but we are extremely proud of our PMark system. And again, this is one of the smallest systems available on the market, just a 9 kilo with 6 nozzles. But more importantly, because of our experience with the vehicle fire testing, our PMark 199, which is for the heavy vehicles, are automatically approved 183. So we actually have 4 system sizes that have individual PMarks.
Great, yeah. So just a brief one on this. We've talked about it throughout the presentation, and of course, we can provide you some more information, and you can be in touch with the team, and probably detailed questions around this. But for us, the key thing that make Reacton the top performance for anything vehicle related for fire suppression, a fire system is no good unless its documentation and training that goes with it is world class. So we have world class documentation. So I would challenge anyone on the call, and I frequently challenge our customers as well, to find a company that delivers clearer and better documentation than we do. World-class training, which is based online, in field. A particular project in Mongolia was classroom-based, it was also online-based, and it was field-based, with recertification every year. That helps us keep engineers certified with new developments on the system. World-class communication, we've got plenty of communication channels with customers and other third parties. So, for us, it's about being 24/7 in the way that we keep communication working with our customers. All of the R&D that you see, all of the animations that you've seen on YouTube channels and on the website are all done in-house, and we also offer those services to some OEMs that we work with. So for us, it's about getting people educated around fire systems, but really for us, it's making sure people are being sold to or making a purchasing decision based on scientific advice rather than commercial advice. And that's where the testing and certification of systems comes in, and the results that you see. And the R&D side is all done in-house. The testing that you see, the fire testing for vehicle systems, we actually own a replica of the rig that Rise in Sweden have, that they perform testing on. So, for us, we're continually playing with systems, we're continually looking at innovations, we're continually looking at emerging risks such as electrical vehicles, hydrogen-powered vehicles. So, and we provide third-party testing as well to certain manufacturers and for some of our military customers as well. And just a quick one, who do we work with? Lots of different brands across lots of different sectors. It's a bus, it's a bus presentation today, but we work with the Ministry of Defence, NATO, a lot of machine equipment dealers, JCB, Liebherr, well-known brands that I'm sure most of you have heard. For us, why the different collection of customers? We're committed to solving our customers' problems. And frequently, we get customers come to us and say they've been offered X, they've invested in Y, and it's not doing the job for them. And what we do with the technical function we have here and the expertise we have in Ed and the rest of the R&D team is develop solutions to our customers' problems. And we pride ourselves at being experts in the field that we operate in, and vehicles is one of those fields. And that's why, hopefully today, it's given, although albeit very brief, and we're 3 minutes over at the moment, but a very brief insight into some of the research and development and technical knowledge we have. And the next webinar is actually based on CNC machines, so it ties in nicely to what I was talking about. We've got customers talking about protection on machining equipment. So funny enough, some of the bus manufacturers that obviously design and manufacture buses also use CNC machines, and we've been speaking to some of them about issues they have on CNC machines, as well as other CNC shops that have fire risks. So it just gives you a bit of an overview. So yeah, that's a real overview on the bus and coach side from Reacton. we finished 4 minutes over, so we keep finishing, I think, about 4 minutes over, and it's really irritating. So we need to work on the 4 minutes. For everyone that joined us today, thank you very much for your investment in time. We're here, we're a totally transparent organisation. If you've got any questions, apart from the questions we'll take in a minute, there'll be an email going out about who you can contact, and the marketing team are on hand to answer anything after the webinar, and there'll be a copy of the webinar going out to you so you can review it at your leisure. So we're just going to go ahead now and bring up some questions. So we've got one from Neil Lewis. How would the Reacton system protect the fleet of electric buses? So the way we go, the way we deal with electrical buses is if we remove the battery from the conversation, because battery protection is very bespoke to the way that or the way you would approach protecting a vehicle. So the battery protection is very difficult because batteries are enclosed in a protective casing, which protects them during accidents. So no one. And there's research, RISE, the Research Institute of Sweden, have a project on at the moment looking at integrating. Sorry, I'm just going to make this full screen. There we go. So yeah, we have a project. There's a project at the Research Institute of Sweden looking at battery protection, but it's still an ongoing field. With electric buses, the biggest risk in electric buses is the control equipment for the batteries, so wiring, control boxes, and typically a number of the system manufacturers and OEMs are looking at how do they protect these certain areas. So whether that's high voltage switchgear on the bus, whether it's control equipment. So there's a number of unique ways you can tackle it. The chemical we use to protect electric buses is by 3M, which is Novec 1230. And that's a clean agent chemical, so it leaves no residue, it's non-conductive, and that typically is used in protecting server rooms and other like sensitive electrical enclosures. We do a control panel system with the fluid as well, but it's also great at protecting those localized risks that exist in an electric bus.
And one thing to expand on from that is the fact that our in-cab notification system has future capabilities of being able to have gas detection. We all know that detecting lithium-ion battery fires at the earlier stage is the only way of really dealing with those fires. Once they start thermal runaway, you're into territories where you're just going to be controlling. But also on buses and coaches, there's really three ways of a lithium-ion battery becoming compromised, and that's from like electrical abuse, from charging, from physical abuse, so if it's in an accident, but then there's also heat. And the Reacton system can deal with the heat side, even with just the dry powder system, where you still have lubricants, you still have hydraulic hoses and everything like that, that can still have fire scenarios. So if we can remove that one, we are in protecting the vehicle as well.
And I think that's I think that's important, and it's something that Transport for London are looking at as well. I mean, our base system that we have at the moment that we presented to you earlier is Transport for London approved, but they're also conscious that electric vehicles are changing, and they're going to change the way that we need to approach suppressing and detecting electrical fires. Certainly the route looks like we all agree that liquid-based systems are not suitable to protect electric vehicles, especially water mist-based systems, because obviously they are conductive, but obviously you need to be careful where you're putting liquid, as we all learn at a very small age. Electric and water doesn't particularly mix very well, and it's not approved for use on a standard basis to use liquid on electrical fires. So I think a key thing for me is it's an ongoing, evolving project. What we tend to do is when you're looking at electric vehicles, you need to look at each application very specifically. And I think that's what we talked about before, is even more so than a risk assessment you would perform on a diesel bus. electric vehicles are unique in every single way. So for us, when we're looking at protecting an electric vehicle, the guys, Ed, and the rest of the team will perform a thorough risk assessment. So I think we'll take that one offline, otherwise we'll be talking about electric vehicles all day. But yeah, it's something that we can deal with. Some more.
Yeah, and we want to obviously mention we do have two types of detection tubes that Reacton have in its portfolio of products, and one of those is the blue detection tube, which has been developed with NATO, which has a higher ambient temperature where it can be installed. So typically people know about the red tube that's out there. We have a blue one which can endure really tough conditions, and again is very quick for detection, but it's also really robust and reliable. So they are some things that are unique to Reacton and very important to come and talk to us about, because we do have lots of solutions.
Yeah. And we've got further detection methods as well with the system. So I think for us, that's we've got, for us, the specific applications that we carry for the detection systems have been proven in the various different fields. So I know that some customers that we've been engaged with have come up with issues with previous pressure loss systems, but we've been through the testing and we developed a different style for that. So, okay, I don't think there's any more questions. So as I said, thank you very much for joining us today. You'll get an email link with a copy of today's presentation. And again, if you've got any questions, don't hesitate to get in contact with us. Ed and all the rest of the contact details will be in the email that goes out. And yeah, thanks very much for joining us, and wish you a good day, and we'll see you shortly on another Reacton webinar. Thank you very much.
Thanks for your time. Cheers.